Alright, good day. So for today we are going to solve the remaining problems regarding on the molar heat of vaporization. But for now, let's start with the practice exercise examples. So we have here the formula of the molar heat of vaporization. We have Q is equal to N multiplied by molar heat of vaporization, where Q is the amount of absorbed heat and N is the number of moles. And of course, we have the molar enthalpy change of the vaporization. Okay, so please take down notes of the following, especially for the formula, because this is important for you to be able to answer the following sample problems and the practice exercise number 1. All right. So I have here a quick sample on how to solve the molar heat of vaporization. Okay, so paano nga ba nakuha itong part ng aking pong solution? Okay, so balikan po natin ulit. Okay, so let me erase this written part ng aking pong presentation. Mukhang hindi siya nabubura, so let me delete this one. And another one here. Okay, let's solve the number 1 problem, which is the to vaporize 50 grams of carbon tetrachloride or CCl4, which liquid requires 9.69 kilojoule at its normal boiling point of 76.7 degrees Celsius and 1 bar pressure. Calculate the molar enthalpy of vaporization of carbon tetrachloride under this condition. Alright, so we have here the following given. So we have here the 50 grams of carbon tetrachloride. We have also the uh, given of 9.69 kilojoule, which is the Q. If we're going back to our formula or equation, we have the number of moles and we have also the amount of absorbed heat by the sample number 1. So we are looking for molar enthalpy change of vaporization. Okay, so let's go back again in our example number 1. Okay, so first thing first, you need to start with getting the molar mass of each compound. Okay, so since carbon and tetrachloride or carbon and chlorine is combined, that is known as compound, let's talk about the mass. Since we're going to get the moles of each compound or each element in a compound para makuha po natin yung pinaka-total. Okay, so let's start with the mass of the carbon. So the mass of the carbon is 12.02 based on the periodic table, and if you're going to research it or search it online, 12.02 ang lalabas. Okay, for the chlorine, we have 35.45 if not mistaken. Okay, so if you're going to look on the molar mass of the chlorine on internet, well, I think it is 35.45, pero it is according to your periodic table. So since sa ating pong carbon tetrachloride, we have 4 molecules of chlorine. So we are going to multiply the 35.45 into 4 to get what will be the final answer, or the summation of the molar mass of the compound or the elements of carbon and chlorine if we combine each other. Okay, so I have here the molar or grams per mole of carbon tetrachloride, which is 153.6 grams per mole. Grams per mole. Okay, so this is the um, ways on how to get the molar mass, especially for the grams per mole of the compound. So this is the first step. So don't forget you have 153.6 grams per mole of a sample. Alright, so we have here the 9.69 kilojoule at its normal. Sir, how about this one? Since based on our equation, Q is the amount of absorbed heat and M is the number of moles. So meaning there's no grams in the equation. It should be no grams in the equation. Okay, so we need to get rid the unit of grams before we proceed to our equation. Alright, so at this point we need to use the 50 grams of carbon tetrachloride to cancel out the grams or the unit of grams of the 153.6 grams per mole, and for us to be able to get the mole only of a given sample. Okay, so let's move on to the to my blackboard rather. All right. So we have 153.6. Okay, so just like let's write it, 153.6 grams per mole of carbon tetrachloride. Okay? So, pagpasensyaan nyo na po ang aking sulat. Alright. So, let's continue. We have 50 grams of carbon tetrachloride. Okay? Now, to get rid the unit of carbon or the grams in the first sample, we need to use the cancellation unit or cancellation equation natin. Okay, so let's start with 50 grams, okay, of carbon tetrachloride. Since it is gram per mole, meaning, pwede po natin ilagay yung ating pong 153.6 grams per 1 mole. Sir, bakit po nasa taas yung 1 mole? Since we're going to cancel out the unit of grams, kailangan natin siya ilagay sa baba. Alright? So, cancel out the unit of grams, cancel out, then multiply 50 times 1 mole, that is equal to 50 mole. Right? Then, divide it by 153.6 and you will get 0.326 mole of carbon tetrachloride. Alright? So, yan po ang ating number of moles. Okay, hindi pa po tayo tapos. Now, since we are looking for the molar enthalpy of vaporization of carbon tetrachloride, so we are going to use our given. So, we have here the 9.69 kilojoule. That is your Q. Okay, any unit or any numbers that has a unit of kJ or kilojoule is known as Q in our equation. Okay, so let's proceed to the to get the molar enthalpy change of heat, molar heat of vaporization. All right, so we have here the value of 0.326 mole of carbon tetrachloride. We have also the given of 9.69 kilojoule of the sample. Now, since our formula is more on multiplication, wherein Q is equal to N times molar enthalpy change of vaporization, we need to derive the formula since we are looking for the molar enthalpy change of vaporization. Okay, so let me teach you on how to derive the formula. Okay, so punta lang ako sa panibagong blackboard. Alright, so I have here the okay, so I have here the formula of Q is equal to N times molar heat of vaporization, or HVAP. Okay, so to get the molar heat of vaporization, we need to derive it into another formula. Okay, so to get another formula, you need to divide both side by N. Okay, why, sir? Okay, since we need the molar enthalpy change of vaporization, that's why we are going to get rid of the number of molecules in this side of equation. And of course, ito na po yung ating panibagong equation wherein H or molar enthalpy change of heat or vaporization is equal to Q, that is Q, over N. Alright, so that is our new equation. I hope nasusundan ako. Okay, so let's proceed to the equation. Okay, so let's say substitute the value of the amount of absorbed heat. So we have 9.69 kilojoule over 0.326 mole. So divide and you will get the 29.7 kilojoule per 1 mole. Okay, ulitin. Lagay ko na lang dito. 29.7 kilojoule per 1 mole. Okay, so that is the correct answer in our first example. Okay, so I hope nasusundan ako. So again, ang ginawa po natin is step 1, get the molar mass of the compound, which is in unit of grams per mole. And second step is to cancel the unit of grams for us to be able to get the number of moles of the compound. Third step is to derive the formula if necessary. Okay? If necessary po na kailangan nating baguhin ang ating equation at kung ang pinapahanap sa atin ay yung molar enthalpy change of vaporization, yun po yung gagawin natin. Pero, if hindi naman po nawawala ang ating pong molar heat of vaporization at ang nawawala lang po is yung amount of heat absorbed, that is Q, you're going to multiply it for you to be able to answer, okay, the given questions. Alright? So, I hope nasusundan ako sa part na yan. So, lipat tayo sa pangalawang example. Okay? So, you empty the contents of a 1 liter bottle of water into pan at 100 degrees Celsius and all the water evaporates. How much thermal energy was required to evaporate this water at 100 degrees Celsius and 1 bar? The density of a liquid water at 100 degrees Celsius is 0.958 gram per milliliter. Okay, so what are the givens here? So we have here the 1 liter bottle of water. Okay, we have also the molar heat of vaporization, which is in the 100 degrees Celsius. So, ibibigay ko po yung given nito. Actually, meron po nito sa slide. Meron pong table akong binigay doon or provide. So, check nyo na lang po kung ano po yung molar heat of vaporization ng ating water in a 100 degrees Celsius. Okay? So, we are looking for what? We are looking for how much thermal energy was required to evaporate this water at 100 degrees Celsius and 1 bar. So, this is our missing. Okay, so you have here the what? You have here the density of a liquid, which is 0.958 grams per milliliters. You have 1 liters of bottle. That is your number of moles. Okay? So, ang hinahanap po natin dito ay yung ating Q. Okay, so Q is missing. If we're going back to our formula, Q is equal to N times molar enthalpy change of vaporization. So, Q is missing. Sir, paano nawawala si Q? Ulitin ko lang po. Thermal energy. Okay, amount of heat absorbed. That is Q. Okay? Liter bottle of water is belongs into the number of moles. Okay? Letter N. Meron na po tayong molar enthalpy change of vaporization, which is 100 degrees Celsius of water. That will be 40.7 kilojoule per mole. Okay, so this is the constant value of a liquid in a 100 degrees Celsius. So this is the molar enthalpy change of vaporization. Okay, so lipat tayo sa aking pong blackboard. Then ilagay po natin yung mga given natin. So we have here the given of 1 liter of H2O. We have the density of a liquid, which is 0.958 per gram per milliliters. We have also the molar enthalpy of a vaporization. Tulad po na sinabi ko, it is constant, 40.7 kilojoule per mole. We are looking for what? Q. Q is missing. Okay, so again, first thing first, you need to get the molar mass of the compound. So we have here the water, which is H2O, and the molar mass of the compound of the water is 18.02. Okay, shortcut ko na. Kasi yung ating pong oxygen is 16, that's 1 naman po yung ating hydrogen. Okay, so the molar mass of the H2O is equal to 18.02 or 02 gram per mole. Okay, so that is the molar mass of the water. I'm sorry, natatakpan ko ata. Okay, so lipat ako sa kabila. Ayan. Okay, so that is our molar mass of the water. Now, since we already written the given in the sample, so given is in the sample, so let's start to the calculation. So don't forget the following. So we have 1 liters of water, density, which is 0.958 grams per milliliters, and molar heat of vaporization, which is 40.7 kilojoules per mole, and the molar mass of the H2O is 18.02 gram per mole. Okay? So lipat na ako sa kabila. Next, blackboard. Okay, so since it is 1 liter and our density is in unit of grams per milliliter, so we need to convert the 1 liter into milliliters. Now the question is, how many milliliters do we have in 1 liter? The answer is, tadaan! Wala po nakalagay. The answer is 1,000. So we have 1,000 milliliters. Okay, so since the density of liquid is already given in the sample, so we need to use that to cancel out the milliliters of a liquid and to get the grams. Okay, so bagal lang natin, no? So 1,000 milliliters times how to cancel the milliliters or the unit of milliliters. So you need to input the 0.950 what? I don't know. I'm sorry, that is grams pala. Grams per milliliters. Alright, so 0. Dito po sa taas yun, 508. 0.908 grams over 1 milliliters. Okay, so just cancel out the unit of milliliters, cancel out, cancel out. Next, multiply. Since there's already a gram in the unit, so let's proceed to the molar mass. Okay, para mas mabilis. So, what is the molar mass of liquid? Ang sabi ko po ay 18.02 grams per 1 mole. Alright, so just cancel out the unit of grams. Grams, sir, paano po yung nakuha yung 18.02? Again, para po makuha yung ating 18.02, you need to get the molar mass of each element, then add or sum all of the molar mass of each substance, then that is the molar mass of the compound. That is your gram per mole. Okay? So cancel out the unit. Now, using your scientific calculator or any types of calculator, so multiply 1,000 times 0.958 times, or no, divided by 18.02, and you will get the 13, no, not 13, I'm sorry, 53.16 mole of H2O. Okay, so nakuha na po natin yung number of moles. I hope nasusundan ako. Okay, i-review nyo lang po ulit yung video para maintindihan natin or maintindihan po ninyo yung ating pong sinasagutan. Okay, so 53.16 moles, mole of H2O. So that is the number of moles na gagamitin po natin for our equation. Remember, our equation is Q is equal to number of moles times molar heat of vaporization or molar enthalpy change of vaporization. Okay, so let's proceed. Remember, meron na kayong given ng molar enthalpy change of vaporization, which is 40.7 kilojoule per mole. Alright, so let's proceed to our equation. So Q is missing, so hayanin natin siya dyan. Our number of moles is 53.16 mole of H2O, open close parenthesis. And remember that your molar enthalpy change of vaporization is written or has the unit of kilojoule per mole. So we need to cancel the mole unit of a number of moles. So 40.7 kilojoule per 1 mole. Ayan. So just cancel out the unit of a liquid. Okay, 1 mole of a liquid. So cancel out the unit, cancel out, then multiply. 53.16 times 40.7 kilojoule, and you will get, of course, kilojoule only. That is the unit for the absorbed heat. Okay, and you will get 2,167.6 kilojoule. So that is the on how to solve the molar heat of vaporization. So don't forget the formula, and of course don't forget to look on the table, especially if we are talking about liquid and the molar enthalpy change of the liquid. Kung wala pong binigay na molar enthalpy change of vaporization sa ating pong sample, so don't forget the constant value of the molar heat of vaporization of a liquid in 100 degrees Celsius, which is 40.7 kilojoule per mole. Okay, so our third example, I hope you can do this. You can solve it on your own. bibigay ko na lang yung final answer. Okay? The final answer in number 3 is it should be 111.51 kilojoule. Let's see kung masusundan ako, no? Yung ating first and second example, um, I hope nasundan ako doon. Itong number 3, i-practice po ninyo yung sarili nyo para masugutan itong number 3. Pero dapat ang product po ninyo is 111.51 kilojoule since you are looking for molar heat. Oh, no, no. You are looking for the how many kilojoule or for the amount of heat absorbed by the liquid. Okay? So, regarding on the practice exercise number 1, you have 3 um, questions that you need to solve. So, kung meron questions, balikan lang po yung first example and second example. Okay? So, thank you for your listening and I hope nasundan ako sa part na to. Bye!